two snakes, one armed with deadly venom, the other with lethal audacity. In the Brazilian Caatinga, the racer snake, Philodryas nattereri, wields rear fangs that inject toxins. But how does it dare to confront a rattlesnake, a predator designed to kill in seconds? Every movement is a calculated risk. Science will reveal how this serpent reads vibrations, timing, and terrain, not with strength, but with lethal precision. In the dry plains of Brazil's northeast, movement means survival. The Philodryas nattereri, known as the racer snake, isn't just fast, it's built for speed. Its long, slender body and keeled scales reduce drag, allowing it to slide through dust and grass with almost no sound. Vision becomes its primary weapon. Unlike vipers that rely on heat pits, the racer depends on sharp daylight vision to detect even the slightest vibration of prey. But beneath that agile body lies a secret often ignored: small rear-positioned fangs capable of delivering venom. It's not a killer by accident. It's evolution's calculated balance between agility and chemistry. The racer hunts lizards, frogs, and sometimes even other snakes, using quick strikes and muscular control instead of brute force. Venom is mild compared to a rattlesnake's, yet surprisingly complex. Scientists have found proteolytic enzymes, substances that break down tissue, allowing the racer's bite to weaken prey gradually. It's a design for precision hunting, not instant death. But when this serpent meets a rattlesnake, the game changes. The rattlesnake's sensory system is one of nature's masterpieces. Pit organs beneath its eyes detect heat differences as small as 0.003 degrees C. Its venom glands are biochemical factories, loading each fang with hemotoxins capable of liquefying muscle fibers within minutes. When two systems like these collide, speed versus strike, biology turns into a duel of milliseconds. The desert floor becomes a chessboard where one wrong move equals extinction. To understand this confrontation, we need to decode perception. The racer's eyes operate almost like high-speed cameras, processing motion faster than a human brain can react. A blink for us is an eternity for it. Its brain converts visual cues into muscular commands almost instantly, creating what herpetologists call a reflex arc. The rattlesnake, on the other hand, trusts stillness. Its power lies in patience. It waits, perfectly camouflaged, reading air pressure and vibration. Two evolutionary philosophies facing each other. One built to move first, the other built to wait for that movement. This is not good versus evil, it's algorithm versus algorithm, coded by millions of years of survival data. Both species occupy similar ecosystems: open fields, rocky terrain, dry forests, yet their strategies differ like day and night. The racer is diurnal, using sunlight to its advantage, while the rattlesnake rules the dusk. Their paths cross where light fades and shadows stretch. In that twilight zone, biology writes its most dangerous equations. Here, temperature dictates everything. Warm scales mean faster reflexes, but also greater visibility to predators. The racer knows this, adapting its color tone to merge with the soil. Each flick of its tongue collects airborne molecules, mapping invisible data of smell and heat. It's evolution's version of radar, converting chemistry into navigation. Science calls it chemoreception. The racer calls it instinct. By now the stage is set. A predator of precision facing a predator of power. But science reveals something unexpected. The racer's courage isn't recklessness. Studies suggest these snakes learn from environmental cues, memorizing patterns of vibration and movement. Their nervous system records the rhythm of danger. This makes each encounter less random and more strategic. When a racer approaches a rattlesnake, it's not entering a blind fight. It's executing stored intelligence. The ecosystem becomes a neural network, where every rustle, shadow, and scent feeds into decision-making. What looks like instinct is actually adaptive memory. Evolution once again hides a lesson. Intelligence doesn't always wear a brain, it sometimes slides on scales. Every predator follows a code written long before thought existed. For the racer snake, survival isn't about strength, it's about prediction. Its entire body operates like a living algorithm, measuring angles, distances, and timing within fractions of a second. When a rattlesnake coils, the racer reads not just the movement, but the microtension in its muscles, anticipating the strike before it happens. This is neuromuscular intelligence, a system so efficient that missing a single cue can mean death. Unlike mammals, the racer's reflexes don't pass through decision-making. The signal jumps directly from eye to muscle, cutting out hesitation. That's how it survives in a world where the difference between hunter and hunted lasts less than a heartbeat. And the rattlesnake, on the other hand, trusts the geometry of threat. Its body forms a living spring, each coil storing potential energy ready to explode forward at up to 2.5 meters per second. The racer's code is different. It attacks in waves. First distraction, then precision. Scientists call this sequential evasion, a movement pattern designed to overwhelm the opponent's predictive system. The racer feints, triggering the rattlesnake's premature strike, then uses its momentum to circle and counter. It's not immune to venom. It simply ensures the fangs never connect. Evolution doesn't need armor when it can design anticipation. This is the art of surviving through prediction, where instinct behaves like strategy and movement becomes mathematics. Each turnum one. Muscle fiber in the racer's body works like a piston, contracting and releasing in rhythmic bursts. Oxygen surges through its blood faster than in most snakes of similar size, fueling speed with precision. The coordination between vision and movement is so synchronized that scientists compare it to a drone's AI tracking system. While a rattlesnake relies on ambush, the racer thrives in open motion. Its defense is offense. This explains why some encounters show the racer approaching, circling, and testing distance repeatedly before committing. It's reading data, vibration, temperature, shadow. Each flick of the tongue updates the equation. The snake isn't reckless, it's calculating probabilities faster than we can perceive them. In the rare cases where the racer decides to bite, its venom isn't meant to kill a rattlesnake outright. Instead, it disrupts muscular control and creates confusion, slowing the target's reflex. The bite is fast, deep, and followed by immediate retreat. Biologists believe this behavior is less about domination and more about disruption. By chemically interrupting the opponent's coordination, the racer gains a microsecond advantage, just enough to strike again or escape unharmed. It's evolution's version of digital interference using biology like code injection. What looks like chaos is, in fact, precision warfare written in proteins and reflex, and we all. Across millions of years, these behaviors have been refined by natural selection, the silent editor of life. Only racers that mastered this predictive dance survived long enough to reproduce. That's why their reflex speed, muscle density, and vision acuity surpass most snakes of their size. They don't just react, they preempt. In neuroscience, this principle is called feed-forward control, a system where the brain predicts rather than waits. The racer snake embodies this perfectly. It doesn't rely on luck or venom. It relies on timing, a predator that wins not by power but by reading the future one frame ahead. And in the desert chessboard, that single frame defines who lives to hunt again. Here the encounter begins in silence. A faint vibration trembles through the sand, a coded message that both snakes understand. The rattlesnake coils first, body tightening like a compressed spring. Its tail buzzes in warning, but that sound is not for the racer. It's for everything else that dares to exist nearby. The racer, motionless for half a second, analyzes the pattern of coils and adjusts its breathing. It knows the strike zone, the direction, and even the temperature difference between shadow and sunlight. When it moves, it doesn't slide, it launches. The ground erupts in dust. What follows is not chaos, but choreography. One measuring distance, the other calculating velocity. The rattlesnake strikes, a blur of muscle and precision faster than a human blink. Yet the racer is already gone. Its body folds sideways, bending reality in a curve the viper never accounted for. High-speed footage reveals that the racer reacts before the strike reaches mid-extension, milliseconds of impossible timing. It circles behind the rattlesnake, tail whipping dust into its sensory pits. The heat map is broken, the signal lost. What looks like luck is actually data interference. By manipulating air movement and dust, the racer hides its thermal signature, tricking one of evolution's most advanced sensors. In that moment, chemistry loses to physics. The rattlesnake reorients, its head tracking vibration more than sight. It strikes again, closer this time. But the racer reads motion like a heartbeat. Each twitch in the viper's muscles translates into geometry. It adjusts, shifts, and glides, keeping its head parallel to the rattlesnake's line of vision. This creates a blind angle, a natural dead zone the viper can't calculate. Scientists studying similar behavior in racers describe it as Evasive symmetry, a form of movement optimization rarely seen outside of predatory birds. The racer doesn't escape in straight lines. It moves in arcs, each curve rewriting the rules of distance and reaction. Then, contact. A sudden twist and the racer lunges, quick, precise, striking the viper behind the jawline where the scales are thinner. It's not aiming to kill but to control. The bite disrupts the rattlesnake's muscles, releasing a mix of adrenaline and confusion. The racer retreats instantly, coiling into defensive formation, its body pulsing with oxygen and heat. Both snakes pause, reading each other again. Around them, time feels suspended. This is evolution's negotiation. Two designs testing whose equation works better. The rattlesnake twitches, sensing its power fading. The racer moves again, silent, relentless, patient. Minutes stretch like hours. The rattlesnake weakens, its reflexes misfiring from biochemical fatigue. The racer advances, not rushing, but calculating. Each strike is a test, each dodge a lesson in precision. The duel ends not with violence, but with control. The rattlesnake lies still, not dead, but defeated. Its nervous system overloaded by stress and venom disruption. The racer slithers away, leaving no sound, no trace, only dust swirling in the heat. To an observer, it looks like instinct. But science knows better. What just happened is neurology in motion, survival engineered through sensory intelligence. Evolution doesn't shout. It calculates, and the racer just solved the equation. Inside the racer's body, the real battle begins. Beneath its smooth scales, muscles flood with oxygen, glucose, and adrenaline in a perfectly timed cascade. Each contraction releases bursts of lactic acid, but instead of slowing down, the snake's blood chemistry neutralizes it almost instantly. This is nature's performance enhancer, a biochemical adaptation that allows sustained speed in extreme heat. Its heart rate spikes up to 3 times its resting level, pumping oxygen with mechanical precision. Scientists studying racer metabolism describe it as a reptile built for aerobic warfare. Meanwhile, the rattlesnake system shifts to anaerobic mode, conserving energy for single explosive strikes. It's power versus endurance, two physiological philosophies locked in conflict. The desert hides nothing, yet most of the battle happens beneath the skin. Neurons fire like lightning storms inside the racer's brainstem. Each pulse sends a signal through the spinal cord faster than sound travels through air. Unlike mammals, this snake's nervous system doesn't rely on cortical thinking. It's pure reflex computation. Sensory input transformed into movement without delay. High-speed neural imaging on related species shows firing rates so rapid that one visual cue triggers an entire sequence of muscle reactions in under 60 milliseconds. It's as if the body predicts movement before the brain confirms it. The rattlesnake, meanwhile, operates through precision timing. One perfect calculation, one strike. The racer operates through continuous prediction, like a supercomputer running live simulations of its opponent's next move. Both are intelligent, but in opposite ways. One analytical, the other instinctual. Two neural languages designed by evolution's endless experiment. Even chemistry speaks during combat. The racer's blood thickens to handle oxygen overload, and its hemoglobin structure binds molecules more efficiently under stress. Every breath drawn through its flicking tongue gathers not just scent, but temperature and humidity data, microscopic signals that feed into its nervous system like a biological radar. The air vibrates, molecules shift, and the racer interprets the invisible. For the rattlesnake, each heartbeat is a countdown. Venom glands contract, preparing another strike, but its internal energy is fading. Muscle fibers begin to tremble, micro-fatigue caused by heat and stress. Both snakes are now prisoners of their own biochemistry, running engines at maximum capacity. The audience sees movement. Science sees metabolism dancing on the edge of collapse. Scientists have recorded micro-temperature spikes during such chases, moments when muscle fibers heat up nearly 2 degrees in seconds. For mammals, that would mean exhaustion. For the racer, it's efficiency. Specialized proteins called myoglobins store oxygen directly inside the muscles, delaying fatigue and allowing longer bursts of movement. This hidden mechanism explains why the racer can sustain pursuit or repeated dodges without collapsing. At the same time, its brain releases dopamine-like compounds not for pleasure, but for control, reducing fear response and stabilizing focus. It's nature's version of performance enhancement, where chemistry and instinct merge. The rattlesnake's physiology, in contrast, is built for singular precision. It can't afford long combat. Its design is to end it fast or lose. And now, its biology is running out of time. When the dust settles, both snakes carry invisible scars. Inside the racer, energy reserves deplete and enzymes begin repairing microtears in muscle tissue. Each heartbeat echoes the cost of survival. Yet the organism learns. Through neural plasticity, its brain reinforces successful reactions, strengthening the pathways that kept it alive. This is how instinct evolves, not in centuries but in seconds. The rattlesnake, even in defeat, contributes to this silent education. Its venom, its speed, its failure, all become part of the environmental algorithm shaping future generations. What the human eye perceives as a fight is, in truth, evolution updating its code. Two serpents, one battlefield, one lesson. Survival isn't just visible in movement. It's written in chemistry, memory, and the pulse that refuses to stop. Evolution never creates perfection. It creates experiments that survive. The racer snake is one of those quiet successes. Scientists studying Philodryas nattereri discovered it represents a transitional weapon, a predator that evolved mild venom not for dominance, but for precision. Its fangs, positioned at the rear of the mouth, show how evolution sometimes prefers subtle design over power. Compare it to the king snake in North America, a non-venomous species that hunts venomous snakes through constriction. Different strategies, same result. Evolution doesn't play favorites. It plays probabilities. The racer snake's method, mixing agility, chemical aid, and sensory intelligence, is one of the most balanced survival algorithms ever written by nature. Even the rattlesnake, often seen as the villain, is part of that grand equation. Its venom composition varies by region, temperature, and prey type, proof that adaptation never stops. Some populations develop more neurotoxins, others rely on hemotoxins. It's nature testing efficiency in real time. The racer snake's encounters with such predators are not accidents. They're feedback loops. Each near-death escape teaches the species what to avoid, when to strike, and how to move. Over generations, those experiences hardwire into instinct. It's evolution's version of machine learning, except the code isn't digital. It's biological. Every heartbeat, every breath in danger, updates the algorithm of survival. Across the world, nature repeats this formula with variations. The mussurana in South America evolved immunity to viper venom, a biochemical shield instead of speed. The king snake developed constriction power and resistance to toxins. The racer chose intelligence and motion. These differences show that evolution doesn't have a single answer. It runs thousands of simulations at once. Each success becomes a living prototype. Watching the racer face a rattlesnake is like watching two branches of evolution argue in real time. One bets on chemistry, the other on physics. Neither is wrong. Both are masterpieces fine-tuned by millions of years of iteration. There's another curiosity hidden in plain sight: fear itself. Studies show that when reptiles like racers face high-risk threats repeatedly, their stress hormones begin to adapt. The initial surge of cortisol eventually stabilizes, allowing focus instead of panic. In human terms, it's like training the brain to see danger as data. This is how evolution rewires emotion into advantage. What appears to be courage is biochemical conditioning. Fear metabolized into precision. The racer snake doesn't conquer fear. It transforms it. In that transformation lies one of the greatest mysteries of life. Intelligence isn't always about thought. Sometimes it's about adaptation under pressure. The more we study these encounters, the clearer the pattern becomes. Evolution rewards perception, not power. The racer snake stands as proof that awareness can rival venom, and prediction can outmatch aggression. Each adaptation, from muscle chemistry to neural wiring, carries the signature of one principle: survival favors those who learn fastest. The rattlesnake remains a monument of lethal design, but the racer is evolution's whisper, a reminder that brains can exist in reflex, and wisdom can live in instinct. When the dust settles, both creatures continue their lineage, carrying invisible lessons for the next generation. Nature doesn't crown winners, it preserves what works. And in this story, both snakes are teachers. In the end, science reveals what instinct already knew. Survival depends not on venom or size, but on precision. The racer snake proves that intelligence doesn't always require a brain. Sometimes it flows through muscles, nerves, and silence. Every movement, every calculation, every pause is a reminder that evolution rewards those who learn faster than they fear. If this story has opened your eyes to the logic behind nature's design, subscribe to the channel, share this video, and continue discovering how every predator, every prey, and every heartbeat hides a masterpiece of survival.